Hey, good morning, guys and gals. Mr. Herr here on this beautiful Monday morning. Today we're going to do our notes through this YouTube video. I'm also going to have the PDF of all the pages up as well. So if I go too fast, you can just come back to the PDF and copy down those pages and all the info, right? But this is to help make that information make sense. All right, so hey, without further ado, we're on page 28. Page 28 is the exterior angle sum, okay? So we're not gonna do all these together, but we're gonna do some of them together, even though they're already filled in, I get it. Exterior angles like A, B, and C, it's its side extended. As long as we have the interior angles, we can take the supplement. Remember, supplement means that they sum to 180. We can take the supplement of the interior angles to solve for the exterior. Like right here, I can do 180 minus 70 to get 110. So I know angle A equals 110. I do the same thing here for B. 180 minus 65, I know that's 115. And 180 minus 45, I know that's 135. Okay. When I fill those in over here, measure of angle A, measure of angle B, and then I take the sum of them. So that means I'm going to take A, which is 110, plus B, which is 115, plus C, which is 135. And guess what? It's exactly 360 degrees. Why? Because we went all the way around the shape. You can fill all of these in, but every single time, the angles themselves will be different, but they're going to sum to 360 every time. Whether it's a quadrilateral, 4 sides, a pentagon, 5 sides. Flip the page here to 29. Whether it's a hexagon, 6 sides, sure enough sums to 360. Or in this case, an octagon, 8 sides, still sums to 360. No matter what measure the exterior angles are, as long as you do everything right, it will always sum to 360. That has test question written all over it. And no, it's not just memorizing the formula, it's applying it, right? Don't act like your boy didn't warn you. Okay, that's page 29. Let's flip it. Interior angles, though, these are different, okay? I used to break it down, and we really used to go through this really thoroughly, but in the interest of time, we're gonna sort of speed it up, and then I'll show you the formula. That formula is big important as well. Every triangle, we've talked about this before, is 180 degrees. We know that 3 sides, no big surprise there. Where here, a quadrilateral is 360 degrees. Do you buy the fact that I could cut this into 2 triangles? As long as you start at one vertex and then you commit to it, I could cut it into 2 triangles. Pentagon is 540. I could cut this. If I start here at the top, you could choose whichever you want. I'm just choosing the top. But once you choose it, you're locked in. Can I split this into 3 triangles? Well, 3 times 180, that's where I get the 140. You're probably starting to see a little bit of a pattern here. Hexagon, 6 sides. I'm going to choose this vertex. Well, there's one triangle, there's another triangle, and there's a third and fourth, respectively. Again, once you choose a vertex, you are locked in. I don't expect you to memorize all those, but I do want you to realize how to find it. And this is at the bottom of 30. This also, test question. We talk about this a lot. We're going to practice it a lot with Mrs. C, and if she's not around, I'll be around. Okay? It's the number of sides in a polygon minus 2 times 180. Just throwing it out there, don't feel like you have to do this. If I had a decagon has 10 sides. So that means for a decagon, I would do 10, oops, sorry if you miscopied. 10 minus 2 times 180. Well, 10 minus 2 is 8. 8 times 180, don't feel like you have to do that off the top of your head. Your boy got your back like chiropract. Guess what? A decagon has 1,440 degrees inside of it. Not more, not less, exactly 1440. You dig? Okay, right here is the big takeaway from this page. And minus 2 times 180, where n is the number of sides in your polygon. Ready? Give it a flip. So we're on 31. A lot of this is just repeating what we said. The sum of the measures of the angles of an n-gon, so that means the number of sides, is the number of sides minus 2 times 180. We already talked about that on the previous page. Duh. Then, the sum of the measure of exterior angles. Remember, exterior, if you go the whole way around, it's like a circle. You go the whole way around, it's always going to be 360. No diggity, no doubt. In fact, I'll fill that 360 in there. Two definitions here. Well, take that back. One definition and then two ideas. A polygon is a closed figure with only straight sides. Sorry for getting the sides on that. That intersect at their endpoints. Okay? So like ABCDE right here, this is a polygon because it's closed, all the sides are straight, and they only intersect at the endpoints. ABCDE, not a polygon, it's not closed. ABCDE, not a polygon because right here, AE and DC do not intersect at an endpoint. They intersect at the middle there. Okay? So to be a polygon, closed figure with only straight sides, that intersect at their endpoints. We have two other types of polygons, and we're going to work on this later on. There's a word called concave. Do you hear the root word there, cave? Well, when I think cave, I think inward dent. Oh, keep it that simple. A concave polygon has an inward dent. A convex polygon has no inward dent. Okay, it could be a hexagon like that. It could be any type of polygon as long as there's no inward dent. For instance, right here, this was convex, no inward dent. Okay, flip the page, we're almost done. Okay. We're going to go in reverse here. Right here, is this convex or concave? Well, dent, 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 dent. It is a concave, and we have 12 sides. That is known as a dodecagon. Okay. Don't feel like you have to memorize the name of dodecagon, but you do want to be able to identify this as concave. Right here, find the sum of the measures of the angles of a decagon. And I realized I misspelled it on the previous page. My bad. That's 10 sides. So we already did this. The number of sides minus 2 times 180. That's where we got our 1440. Okay. Number 3 here. We have a quadrilateral. Quadrilateral is 360 degrees because it's number of sides, 4, minus 2, which is 2, times 180. That's where we get the 360. So X and Y here, notice, it's an arc with a line. Don't let that line fool you. It means arc with a line, arc with a line. These two are the same. So I can do X, because I don't know what it is, plus X, plus 90 from the right angle there, plus 100. Oh, each one of these then is 85 degrees. Slide it back on up. Right here, another big concept that we'll talk about tomorrow again. A regular polygon is a polygon that has all congruent sides and angles. No matter how many sides, no matter how many angles, they are all the same. So like a regular polygon, if it's a quadrilateral, which is 4 sides, well, if they're all the same angles and sides, that's a square. Okay, we'll work on these sort of things, but really make sure we have that definition down. Then last but not least, flip the page. We're not going to do much on 33. We are, though, going to talk about this summary. Okay, jump around a little bit. The sum of the interior angles of a polygon, well, that's the number of sides minus 2 times 180. We talked about that formula before. Now, these two here are kind of new, but it's just applying. One interior angle of a regular polygon. Remember, a regular polygon, that means all the angles are the same. So we find the number of degrees in the polygon, number of sides, minus 2 times 180, divided by the number of sides. Okay. Some of the exterior angles of a polygon, we said no matter what the shape is, it's 360 degrees. Lastly, one exterior angle of a regular polygon, well, that's 360 divided by the number of sides. Okay. Hey, that's it for notes today. Page 34 is our homework. I have the key online. Peace.